Alright, so let's say you're given this equation, and the question says to find the derivative of the function using the limit of integration equation. What is the limit integration equation? The derivative of a function f of x at a point x can be defined as this equation below. This is the limit of integration equation, where f of x plus h is the function a little bit to the right of x. F of x plus h minus f of x is the measured change between the 2 points, i.e. the slope, and h is the distance moved. So when we take the limit as h goes to 0, this makes that change extremely small, which yields the instantaneous rate of change, i.e. the slope of the tangent line, which essentially just means we get the derivative to the function. This is better seen graphically. So we have our function at f of x, and then we have our function of f of x plus h a little bit to the right. We can draw our slope line here. As we take the limit as h goes to 0, this second point is going to get smaller and smaller, yielding the slope of the tangent line at f of x, which is what we're looking for. And if you remember the definition of a derivative, when we apply the derivative to a function, we should get the slope tangent to the curve, which is also representative of the instantaneous rate of change, which we do. So we can apply this equation to our example. In our example, we get y is equal to x squared. So y is representative of f of x. And so f of x plus h is equal to y of x plus h. Plug in x plus h for x, we get x plus h squared. F of x is going to be equal to y, which is equal to x squared. So we can plug both these values in. We can expand and simplify the x plus h squared bracket, which we get this expression here. We can plug it in. And then we can do some simple cancellations. And then we can cancel out h from the top and bottom. Now we can take the limit as h goes to 0. And so as h goes to 0, h is just going to go away. It's just going to be 0. And we get this for the final answer. So this is our derivative of the function y equals x squared. But is it correct? We can use the derivative of a power rule, which we discussed previously. If we use this method, we just bring the 2 down from the exponent, and then we subtract 1 from it, and we get this for the answer. And we can see that they're the same. So we can conclude that both methods work and yield the correct answer.